Good morning, everybody. My name is Paresh Rathod. I'm from Google in database engineering. Nikhil told me that there is no lightning talk in the morning, so make your talk super lightning. So I'm going to squeeze in a 3-hour session into 15 minutes and hope to give you a bird's eye view of how we have been thinking about databases, especially in the era of AI. And what journey have we traveled and where we are with it. We have a separate session later in the evening, actually, which gives a deep dive into that. Before I get into databases, actually, Google has been building the planet-scale applications, some of our favorites, some of us that we use every day. All of these applications have been AI-infused for years without us knowing that they are AI-infused. And they are running on an infrastructure which is an AI-ready infrastructure. Getting the databases ready for the AI era, one of the first foundational piece is to get your AI infrastructure ready. And what does that mean, actually? The AI infrastructure, right from the underneath subsea cables to your data centers, firewall, to your compute and segregated infinite scale compute and storage mechanism, to a cloud that is running on top of this data center, and in the AI era, the models, especially in context of Google, the Gemini model. How do you train this model on the hardware? A hardware that is Google's proprietary hardware, which is TPU. So think about owning the entire stack of the AI infrastructure is what we call the AI-ready infrastructure, which is first foundational piece of making your databases AI-ready. The second thing that we are looking at it is, what does an AI-ready database mean, actually? What constitutes an AI-ready database? If you start to think about it, databases have been doing SQL and SQL searches. We store the data, we search the SQL data. In the AI era, we have to go towards beyond SQL. We have to go towards semantic processing, hybrid processing, multi-model processing. We have to look at how a database connects to a model anywhere. Any model, anywhere. To start thinking about natural language processing from natural language to SQL, which enables actually agents, humans, developers, to start to build applications and connect to the SQL in a very natural form. You would start to see a lot of vibe coding, which is going to be more about prompts, and code my application, write my SQLs. One more very important foundational piece, actually, is about integrating with the open systems and open ecosystems. Examples, LangChain, Llama. There are various infrastructures that are evolving, OneMCP. How do you make sure that your databases are actually tightly integrated with that part? I think these 4 aspects, we kind of tend to look at it as an approach in making a database ready for an AI era. But that's not the most important part, actually. When you start to look at it, the data are in various shape and form. An application, which is a generative AI application that wants to access the data, which are either a structured, unstructured, transactional, analytical, of various size, shape, and form. And they all require various different processing. At Google Cloud, we have a very diverse portfolio of databases from different data models, in-memory to relational, to document, to key value stores. All of these, and the real kicker, actually, to be honest, is not about that each of these databases work in isolation, but they work interoperability, and they're deeply connected with the rest of the Google Cloud system, and also a very important Vertex AI system that hosts the model in the context of the Google Cloud. Closer to home, I learned yesterday, actually, Nikhil said about we are all part of a cult, and I'm going to use that a lot. We all adore Postgres and the work that the community has done for years, and each one of us in our shape and form that we have been contributing to the community and kind of innovating around it. At Google Cloud, we provide 3 Postgres-based services for 3 distinctive journeys. The one journey where the customers would like to move to cloud from an on-premise. It's like a lift and shift. For that, we have a Cloud SQL. This is an open source, fully compatible Postgres version, which is managed by Google. The second is AlloyDB, our customers would want to modernize the application while they go to the cloud. And here, Alloy, by the name Alloy, which is a mixture of metal to make a better metal, we bring the goodness of Postgres and goodness of Google together to make AlloyDB. It's an HTAP database, actually, which is a transactional, analytical both together with a lot of AI differentiated capabilities. Third, last but not the least, Spanner. Spanner is a multi-geo-consistency database that allows you to transform your application. If you would like to have a true consistency, global consistency part, that's where you kind of go towards it. The first two that I spoke about is 100% compatible with Postgres. You bring any Postgres application, works as is with Cloud SQL and Alloy, and we provide a Postgres interface for Spanner. Just a little bit about Cloud SQL. We have fully managed Cloud SQL. It provides high performance, trust reliable, and it's completely 100% Postgres open source is what we build a managed service around it. We provide two different versions. One we provide is Cloud SQL and E+. And E+ is the version that provides an additional performance on the basis of the hardware infrastructure and an optimized, finely high-tuned defaults. To complement Cloud SQL, actually, for the AI era, we provide a number of AI capabilities with Cloud SQL. From integration with the PG vector, which is HNSW vector, actually, that allows semantic processing along with the SQL, to be able to also do a model management, able to connect to OpenAI, able to connect to Gemini, or any model of your choice anywhere. Also, we have things of the nature that allows us to connect to the various frameworks, whether it's LangChain, whether it's Cloud SQL, AI Studio, et cetera, And also, we provide the complete life cycle using the Gemini Cloud Assist and Code Assist, where you can actually deploy, do an application modeling. You could do various sorts of things, actually, with a very simple interface with Cloud SQL. AlloyDB, you can think of AlloyDB as a 3 different product built in one. Okay? It's an operational database. It's based off Postgres. We support PG14 to PG18. When you look at AlloyDB, it's a completely compute and storage disaggregation. We have a very interesting technology called columnar engine. We can double-click in the session later. The columnar engine that allows us to actually create the AlloyDB, not just as an OLTP, but an OLAP database as well. We provide a primary and 20 read nodes, actually. Our persistency remains the row format, but we are able to materialize using the columnar engine the columns in memory. Thus, you can actually do both OLTP and OLAP in a single database. There's no ETL, and there's no deduplication of data. You can look at the numbers. They are staggering, but you can kind of start to think about it as an open heart surgery of Postgres, yet work very compatible 100% with Postgres. We have made AlloyDB as an AI-first database. The approach has been to relook at what it takes for a database to be AI-ready, and how do we differentiate in that. It provides a state-of-the-art query engine, natural language, vector search, and I'll speak a little bit more about that part. Alloy, you can enjoy the goodness of Alloy by coming to Google Cloud. But at the same time, if you'd like to enjoy the goodness of Alloy, you need not come to Google Cloud as well. You can enjoy that on Azure. You can run it on AWS. You can run it on your private cloud. You can run it on your data center. You can actually run it on your laptop. So Alloy Omni allows us to have our customers stay where they want to be, but yet enjoy the benefits of Alloy, the benefit that it brings over the top of their Postgres systems. The recent innovations that we have done in context of making Alloy and AI ready is what we call as a power search, AI-powered search, which essentially is go beyond SQL to a hybrid search. Also look at how we can actually bring the database and the model knowledge together. And look at the natural language processing, thus by be able to convert the natural language prompts into a SQL, but more importantly, and highly performant. We heard a talk from Professor Jayant Haritsa yesterday that how a different query can result into a great performance and not so great performance. So it's not just about converting a natural language into a SQL, but how do you do that in the most performant way, and secondly, the most secured way. Alloy provides an industry standard vector search performance. It has both the HNSW, that is a PG vector graph-based technique, also a 10 plus years of Google's research, which is called SCAN. It's a tree quantized based technique that allows us to store the vectors in a smaller footprint, both at the disk and in the memory, and thus by allows us to do a lot more faster search. When you look at the vector and the semantic search, it's not just about being able to store a vector and scan a vector fast, but an entire life cycle around it, actually. The way we have been thinking about it is that we don't care how B-tree works underneath now. It's been 25, 30 years of evolution of B-tree. That's the goal for vector index. You need not worry about how do you set and configure a vector index. We provide a zero-knob vector index. We provide the entire life cycle around it such that if the index grows, it auto-maintains. And it reduces the need for auto-indexing every now and then. We are also looking at, and our aspiration actually is, take the HNSW PG vector index and infuse and supercharge with columnar engine. Thus, you will be able to see a high performance, actually, that you will see on the HNSW as well. But start to look at it. These are all techniques. The other vision that we have is to be able to build a super index on the top of it. Thus, hide all the complexity underneath, whether you are using a graph technique, whether you are using a tree technique, whatever that might be, but your semantic search works fast. Okay? Hybrid search. We are seeing a lot of use cases, actually, where it's not just about SQL and semantic search, but also a full text search along with it. So Alloy provides in a single SQL an ability to do all three of these. And when you combine all of that together, the interesting part is how does it work faster? That's where Alloy has innovated a lot, and it has some technique called an adaptive filtering that allows our optimizer to decide, should I do a pre-filter, should I do an inline filtering, should I do a post-filtering, actually. So a lot is about not supporting all together, but supporting all together such that actually is working as fast. All of this is great, but all of that works on your data in your database. Your SQL search, your semantic search, your full text search is all about the data that resides in your database. The LLM has a knowledge, which is a world knowledge. And let me give you an example. An example here is like, for example, a customer wants to ask for a bridesmaid dress for a summer wedding in Santorini. Now, if you think of this prompt, it's about the location, it's about the climate, and it's about the style of the dress. Your product catalog may not know all three of these, or may not even have that, actually. So your SQL search, your semantic search, your full text search may not help you. But an LLM can help you. And how do you do that in a construct of a single SQL statement is the power of AI functions. If you look at the SQL on the right side, this is what it does. It actually uses a function called AI.rank provided by the LLM. We prompt it that, hey, score these dresses, a summer wedding in Santorini, on the scale of 1 to 10, from bad choice to a great choice. Just by pure this SQL, you do not have any data about the climate, you do not have any data about the city, you do not have any data about the style, but you're able to leverage the power of LLM in the construct of your SQL and able to actually rank your products that exist in your database. We provide a number of AI functions, from rank to generate to summarize, and we have introduced a new function called times FM, which is called AI.forecast. So think of it like you have your sales data in your database, and you could use a forecast function, actually, with the help of the LLM, and you can forecast what my sales might be. I spoke about the natural language to SQL. The two main important part is to make sure that the query written actually is highly performant. and how do you validate that aspect? Those are the key aspects that Alloy looks at it. And the second and the most important part is how secure it is. Essentially, you want to make sure that your natural language does not have an access to all of your data. So you can define using a technique called parameterized SQL secure view. Thus, by you can define what a natural language can access and what a natural language can't access. These are the primitives of security primitives built in to do a natural language to SQL search. MCP toolbox, we provide an MCP toolbox that allows us to connect to any databases actually that provides of the Google Cloud. Allows the agents to write applications, get the database context, build the new generation applications together. We also provide what we call as an advanced query insight. This is, you want to know, hey, why is my query running slow? What are my top slow running queries? What is the query plan associated with it? Are there locking issues with it? Et cetera, et cetera. What is a blocking query? Why is it blocked? What's it blocked on? And such forth. But if you look at that's on the left, which we already have been providing for last few years. But on the right is about AI-assisted troubleshooting. So what we have done is that what we built over the years, we infused the power of LLM to that. Thus by not just observe, but you could actually ask that, hey, can you analyze this query for me? And it'll come up with an hypothesis, a root cause, and set of recommendations for you to be able to troubleshoot that problem. You could also ask things like, hey, why is my database load high? And set to figure out as to why is it high in your running system, actually. Okay? It's on the basis of the stats that are there in your running system, and combine the power of LLM to be able to provide you the root cause analysis, hypothesis, and the recommendations. Not just at an instance level. Now, you can get your observability troubleshooting for a particular instance. But for a customer, they might be running thousands of Postgres instances. They might be running hundreds of Alloy. They might be running thousands of MySQL or spanners or whatever that might be. And they want to know a fleet aggregated view, which is to say that, hey, across my entire data landscape, what is my health posture? What is my security postures? Where are my security vulnerabilities? Did the backup failed across my entire landscape in last 7 days? If so, what were the major errors? Such and such forth, actually. So you could get an observability from an instance to a fleet aggregated level, actually. A database center allows you to do all these sorts of things. And we infused a lot of AI techniques around this topic as well. So you could actually interact with a prompt language as well. Last but not the least, actually, what I would like to say that we have a very young journey when it comes to contributing to the open source. We have a high aspiration. While our young journey, actually, we have contributed with code contributions, with consults, et cetera, et cetera. We have also had a PG day at Pune office at Google, and we'll continue to do so. But last but not the least, actually, there's lots of ways to contribute, actually. We learned that, actually, yesterday. One of the ways that Google thinks that we tend to believe that we contribute is in the thought leadership of bringing techniques such as columnar engine concepts to a Postgres ecosystem. Techniques such as bringing the AI to the Postgres ecosystem. Those are some of the things that we would like to move the industry forward, our product forward, and this ecosystem forward. Thank you so much.